Okay, so continuing with our little review of cartography to get ready for collecting good quality GPS data, we need to review different coordinate systems. So the first one we'll talk about are geographic coordinates or geodetic coordinates, which are latitude and longitude. They're angular coordinates, they're expressed in degrees, and that's one of the reasons that actually makes them a little harder to use sometimes. But it's easy to understand this by looking at a globe. We have the poles, we have the equator. Latitude measures north and south on the Earth, and lines of latitude are called parallels because they are equidistant and parallel from each other. Lines of longitude, they run north-south, but they're going to measure where we are east-west. And lines of longitude are called meridians. So let's look at each of these in a little bit more detail. So the network of these lines of latitude that measure our distance north-south and the lines of longitude that measure the distance around the globe east-west together are called our graticule. And lines of latitude and longitude cross each other at right angles. And together they create our Earth's grid or graticule. So here we have the equator, which is 0 degrees of latitude, and our parallels are lines of latitude, and our meridians are lines of longitude. So, well, let's talk about longitude first. Our meridians represent longitude. All meridians are what we call great circles. So if we took a meridian and we sliced a plane through the globe at the meridian, we would create two equal hemispheres of the globe. So a great circle cuts a sphere in two equal halves. 0 degrees of longitude is at the prime meridian, which goes through Greenwich, England. And that has a value of 0 degrees of longitude. 180 degrees is opposite on the other side of the globe, and that's 180 degrees. And we can measure longitude to the east from the prime meridian or to the west. So here in Colorado, we are west of the prime meridian. So when we express our longitude, we always have to also say that it's west, or sometimes we can use the minus sign. So we can say it's minus 108 degrees of longitude. So notice that our meridians are spaced farther apart at the equator, and as they move towards the poles, they get closer and closer together. So meridians, lines of longitude, are not parallel to each other, but they do cross the parallels at a right angle. All right, so our lines of latitude. So the equator here is the only line of latitude that is a great circle. So if we were to slice the globe at the equator, we would get two equal halves. So the equator is a great circle. That is our 0 for latitude. If we move north, then we're increasing in latitude. If we move south, then we have to designate that we're headed south, or sometimes we'll use a negative sign there. So our other parallels are what are called small circles, because if you slice through the globe there, you get two unequal parts, a bigger part and a smaller part. So small circles don't cut the globe in half. Parallels are always equally spaced, they're always parallel to one another, and they're always the same distance apart. So geographic coordinates are expressed in angles because they are spherical coordinates. So if we pick our location here in Grand Junction, Colorado, and we want to get the latitude, what we're measuring is the angle. If we start at the center of the globe, and we take the angle from the equator 0, the angle up to Grand Junction, which ends up being an angle of about 39 degrees. So our latitude is about 39 degrees north. And then to get our longitude, from the center of the Earth, we're going to look at the angle from the center of the Earth, starting at the 0 meridian, and we'll go west till we hit Grand Junction, and then ends up being about 108 degrees. So we're 39 degrees north, 108 degrees west. And this diagram here helps explain that a little better. So we go from the center of the Earth, and this is showing the location of New Orleans. The latitude is this 30-degree angle transcribed. If we start at the equator and we go up 30 degrees, then we hit New Orleans. And if we start here at the prime meridian and we go west 90 degrees, we get to where New Orleans is. So in order to express fractions of a degree, we can do that in just decimals, in decimal degrees, or we can use minutes. There are 60 minutes per degree, and then if we need to express fractions of minutes, we can use decimal minutes. So we can say 20.12 minutes, or we can convert that 0.12 into seconds, and there are 60 seconds per minute. So when you're using your Garmin, in the setup, do you remember we looked at the different coordinate systems, and if we were at the very top of the list, the choices we had were degrees, minutes, seconds, degrees, decimal minutes, and decimal degrees. And that's just saying, okay, you're in geographic coordinates, these are spherical or angular coordinates, and there's some different formats we can represent the fractions of the degree in. And that's all you're choosing when you choose that. You're just choosing the format that you're going to present the data. If you're going to input coordinates into ArcGIS from like a text file, and their latitude and longitude, they have to be in decimal degrees, because there's no way to tell ArcGIS these are minutes and these are seconds. So if you're going to take a text file and it needs to be in geographic coordinates and latitude and longitude, you want to import to ArcGIS, it has to be in decimal degrees. Also, your GPS unit is storing the data, the raw GPS data is always in lat long and decimal degrees. If you say you want to look at your GPS data in UTM, it's going to take that raw data and it's going to convert it just to display it to you, but the raw data stored in the GPS unit is always in lat long and decimal degrees. The only time it gets changed is when we export to a shapefile, and that's when we actually change the georeferencing of the data. And we're going to kind of review this over and over again in the semester because it's a kind of important point.